Hello everyone, welcome to my channel Similarity. This is the third video of the matrices series, and in this video we will discuss how we can transform using matrices, okay? And by transform I mean translation, rotation and scaling. So the way we do this, basically let's say I have a point P and I want to translate this point along some vector. So what we do, we basically multiply this point P by a translation matrix. If I want to scale this point, I will multiply this point by a scaling matrix. If I want to rotate this point, I will multiply this point P by a rotation matrix. And by point P, I mean the coordinates of the point P, okay? So this is the overall idea behind this. And don't worry, I'll explain everything in this video. So, okay, so this is our point P here. And let's say its coordinates are x, y and z. Now what I want to do, I want to move this point along a vector v whose components are a, b and c. Okay. So what we normally do inside Houdini, we basically add the corresponding components to to translate a point. I mean that's what we normally do. So we write something like this inside Houdini: v at the rate p equals v at the rate p plus v, where v at the rate p is the position of this point p. So what we get? We get x plus a, comma y plus b, comma z plus c. Okay, so these are the new coordinates of the point P after translation along the vector v. So now I want to do this same thing using matrices, and like I already told you, we will do the matrix multiplication. Okay, so what we do, we multiply this point P by a translation matrix. Now before I do the multiplication, let me show you how this matrix actually looks like. So this matrix looks like this: 1 0 0 0 1 0 0 0 0 1 0 A B C and 1. So this is a 4 cross 4 matrix. Okay, so that's how our translation matrix looks like. And now if you remember, if you want to multiply a vector by a matrix, first this vector is converted into a matrix itself. Okay, so this is a point P, this is a vector here, and first we convert this into a matrix which looks like this here. Houdini internally converts this into a row matrix. Okay, remember this: Houdini does not convert a vector into a column matrix like this. It basically converts it into a row matrix, and then we multiply this by a translation matrix here. And also if you see here, basically this is a 1 cross 3 matrix because it has 1 row and 3 columns, and this is a 4 cross 4 matrix, it has 4 rows and 4 columns. And if you remember, I told you in a previous video that to multiply two matrices, the number of columns in the first matrix must be same as number of rows in the second matrix, but this is not the case here. So what Houdini does, Houdini internally adds 1 here. So now this is converted into 1 cross 4 matrix. Okay, so if you do the multiply right now, what you get x plus a, y plus b and z plus c, and then 1. So you see, you get the same result here. So that's how we translate a point using matrices, using the matrix multiplication. Okay, sorry. Okay, also in Houdini, you don't need to create this translation matrix by yourself. There's a function called translate, which basically creates a translation matrix for you. Okay, now let's jump inside Houdini and see how this works. So first let me add a sphere here, and now I will add an attribute wrangle here. Next I create a vector, let's call this move, and create a parameter here. And now we will create a identity matrix called mat. And don't worry, I'll explain everything once the whole code is done. And then we create a translate function. Basically this function gives us the translation matrix. So it requires two input, first a matrix and then the vector. Okay, So it basically converts this identity matrix into a translation matrix, right? And then we multiply, you know, every point by this translation matrix. Now let's just check if it is working or not. And you can see this is working correctly. Okay, now let me explain you everything in this code here. Okay, so the first thing we did, we basically created a vector, by which we want to move the sphere, or you can say all the points of the sphere, right? And then we created an identity matrix here. This matrix is called mat, and then we supplied that matrix mat inside the translate function and our vector move. So basically what this translate function does, it converts this identity matrix into a translation matrix, right? And then we multiply the translation matrix by all the points, and we get the desired result here. So we can with this we can move the points, and you see here this is what we did here also. So now you must be thinking, why we need a identity matrix, why not some other matrix? Because if you remember in your previous video I have told you, when we multiply any matrix with an identity matrix, we get the same matrix in return. So if you remember, I told you this, that let's say I have matrix M here. If I multiply with this by an identity matrix, we get the original matrix back. Okay. So basically, multiplication with an identity matrix, doesn't change the matrix itself, right? So if we supply some other matrix here, so that means that matrix already had some kind of data in it. So now if you convert that matrix into translation matrix, then and then you multiply that matrix by the points, then you won't get the correct result. That's why we are using the identity matrix here, right? And that's how we do the translation using matrices. And now we will see how we can scale using matrix, right? So let's say I have a cube here, right? And the corner of this cube has a point P whose coordinates are x, y, and z. Now I want to scale this point by A in the x direction, by B in the y direction, and by C in the z direction. Also, let's create this in the form of vector as well. Let's call this scale vector. Now I want to scale this point by this amount in x, y, and z direction. So what we do, we basically normally in Houdini, what we do, we multiply these two vectors, right? That's what we do. So we write something like this: v at the rate p equals v at the rate p multiply by vs. And what we get? We get ax, by, and cz. So that's how we scale points inside Houdini. So now to get the same result, again what we do, we multiply this point p by a scale matrix, and uh, this is how the scale matrix looks like: a 0 0 0 0 b 0 0 0 0 c 0 0 0 0 and 1. This is how scale matrix looks like. This is also 4 cross 4 matrix, and again we write our point p here in the form of matrix x, y, and z. And also we need to add 1 because this is a 4 cross 4 matrix. That's why Houdini internally add 1 here. And now when you multiply, you get the same result: ax, by, cz, and 1. See, you can see we get the same result again. So to create this scale matrix, we also have a function called scale inside Houdini. So let's see how we can do this. So let me create a attribute wrangle here. So first we create a vector called scale. This is the vector of the scale. Basically it tells how much we want to scale in each of the axes. Okay. Basically this vector gives us the amount, scale amount. Okay. And now we create our matrix here called mat. This will be an identity matrix. And again, we use the scale function, right? And we provide our matrix and then our scale vector. Basically, this scale function converts our identity matrix into a scale matrix, which when we multiply it by our point will be scaled. And now let me check. So you can see our object is gone because our scale is 0, 0 right now. So let me push that to 1. And now if I, scale in X direction, you can see it is scaling. Let me scale in Y also. And let me scale in Z also. So you see here, our scaling working perfectly fine. And so this is how we do the scaling using matrix, right? Now let's see how we can rotate using matrices. So similarly, the way we do the translation and uh, scaling here, we do the same thing with the rotation also. So we basically multiply our point P by a rotation matrix. But I won't be showing the rotation matrix here because basically rotation matrix is kind of complicated. So if you want to know how this matrix looks like, you can use the web and see it in the Wikipedia or something. But I'll show you here. So this is basically a Wikipedia here, and you can check how the rotation matrix looks like. So for 2 dimensions, right, it looks like something like this, and for 3 dimension it looks something like this. But you don't need to remember all these things because this is done internally by Houdini, so you don't need to uh, put efforts in this maths here. But if you are curious, you can definitely check it out in the Google or something. Okay, so what we do basically, let's say I have a point here and point P, and I want to uh, rotate this point along some axis. Let's say I want to rotate this point along this which axis this is, X, Y, and Z. Let's call this, these are the 3 axes, right? And I want to rotate this point along the X axis here by angle theta, right? So for this translation matrix, we have to provide 3 things. We have to provide it the angle, we have to provide it the axis, and we have to, okay, I think this is it. These are the 2 things that we have to provide. And then when we multiply this matrix by our point P here, our point will get rotated by angle theta along the given axis we have provided. Okay, so let's see this in action inside Houdini. So let me create attribute triangle here. So but before I write anything, let me show you the rotate function first. So this is a rotate function. Okay, so this function basically gives us the rotation matrix, which when multiplied by the point, our point will be rotated. So you can see here, this function requires 2 things. It requires a matrix, and it requires the amount by which you want to rotate and the axis along which we want to rotate. Okay, and also remember the amount, actually the angle here, the amount represent the angle here, and this angle is in radians, right? So again we need 3 things: matrix, angle, and axis. Okay, so first we create the axis here. Let's call it axis, and we write CHV. So this is the axis along which we want to rotate our sphere, and then we write float angle CHF. Also, if you remember, I told you this angle is in radians, so we will convert it into radians. And then we create our identity matrix here. And then we create our rotate function here. So first thing it requires is our matrix, then our angle, and then the axis. Okay. And now when we multiply our points by this matrix, you get the rotations. So first let me create the axis here. So let's say I want to rotate it along the y-axis. So let me write 1 here, and this is our angle. Okay, I think angle is very small here, so let me change the range of this. Okay, so now you can see we are rotating along the y-axis here. Okay, also if you can change this to something like this, and now you can see we are getting this weird rotation here. And why is that? Because if you know check the documentation here, you can see the axis that it requires must be normalized, and we don't have that right now, so let's normalize this. And now when you rotate it, you can see this is rotating perfectly fine. Okay, so that's how we do the translation, scaling and rotations using matrices. And this is it for this video, and in our next video we will see some examples of matrix transformation. And if you find this video interesting, please like this video and subscribe my channel. I find that really motivating. And thank you for watching this video. See you in the next video. Bye.